Hello, class. From my own office here, I will start lecturing for our trig class. We're going to start in section 3.1, which deals with the definition and descriptions of angles. Hopefully everybody's had introduction to angles in some sort of geometry class, maybe sooner or way back when, in my case, with regard to geometry. So the idea here is I will be splitting these lectures up into smaller chunks of videos and uploading them to our Brightspace account so you could watch them at your leisure. And then during our regular class time, we'll be available to answer questions and go over some more of the more complicated subject matters as well. So with regards to what we're going to talk about in section 3.1, and these are the main topics: the idea of an angle, definition, and how to measure it. And there's two ways to measure it: radians and degrees. We'll talk about some application aspects of angles and do some real world problems. Hopefully the last one will be a fun one as well. Just to remind you, these slides are uploaded to Brightspace as well, so you'll be able to take a look at them between the slides. I will be flipping over to a whiteboard shortly and doing some examples. Try to mimic the best we can the in-class lecture experience. So with regards to the idea of an angle, here's a little bit of a definition with regards to that. But the idea of an angle is that if you have two lines and the distance that the opening of the two lines is the actual angle that we're trying to measure. And you can see, again, some definitions. Don't worry too much about initial side, terminal side, vertex, etc. But the idea of that opening, as you can see, the pink or red line in between there, is the idea of an angle. And so what we're going to do in trigonometry is to be very diligent on how we end up defining the angle and the idea of measurements. And the first idea that I think that is really important is the idea of where is the zero angle. And that's where this idea of initial side comes in here. And if you see on the slide in figure 1.2, the initial side is always defined by the positive x-axis with regards to the Cartesian coordinate plane. So if you take a look here, and fortunately I can't go right from there to the whiteboard, but if you take a look at here and I just draw the Cartesian coordinates here, I'll do my best. And so if you see this, this is the positive x-axis over here, and this is the positive y-axis over here. So by our definition, this positive x-axis is defined as the 0 point for the angle. And so with regard to that, as we take the line and rotate it either clockwise or counterclockwise, from the positive x-axis, we'll measure that distance between those two lines, and we'll end up getting our measurement for our angle. And so another important aspect of the angle is that an angle has a positive measurement and a negative measurement. And the idea of going counterclockwise. And so what we mean by that is that if you're starting on the positive x-axis and you move to the left. So the idea of moving from the x-axis, positive x-axis to positive y-axis would be moving to the left. And then if you move to the right or you go down to the negative x-axis, that would be the idea of counterclockwise. So let me kind of show you what I mean here on the whiteboard to make sure that I said that right. So the idea here is that if we have the x-axis right here, and this is our 0 point, if we go this way, which would be counterclockwise, that is the positive direction. And if we head this way, which is in the clockwise direction, that would be the negative angle. And so, again, just to set up the definition so we could define all these functions. And they're all defined by this idea of a measurement of an angle. And just like in numbers, right? Just like in the old number line, if we go over here to the right, that's positive, right? +1, +2, +3 on the x-axis. And if we go to the left here, that is negative. You know, -1, -2, -3 on the x-axis. So same types of concepts with regards to that. I'm so tempted to say, are there any questions? But obviously there is none since I don't have a class right now. I'm just doing this video. So we're all getting kind of used to this. So the idea of measurement of angles, and there are two types of measurements for these angles. One is in radians, and the other one is in degrees. And I just want to be bluntly honest with you, my mind always thinks in degrees. So when I do these problems as we continue down the trig path, I usually convert radians to degrees and then back and forth if I really have to. But the idea of radians is the idea of thinking about the distance or circumference around a circle. And so as you can see here in the figure 5, we have a nice circle with a radius of r, and the radius is defined from the center point of the circle all the way to the outer edge of the circle. And the circumference, which is s, is the distance around the circle. And so if you take a little bit of a thought process with regards to these measurements, if you think about this now, we're going to have this idea of a radius here, and this distance around is s. And so say like I take this distance to here. So this measurement here we call angle, and we usually use theta for the angle. And the idea with regards to the definition of this angle is that the angle is defined by the circumference divided by the radius. And if you think about this, and this is what makes radians an important idea in real world applications, is that it is a dimensionless quantity. And what do we mean by that? Well, if you think about that, say like I said, R in this case was 1 inch. And say like I said, S, the circumference in this case was 5 inches. So if I do this division here, we have 5 inches on the top, right? And 1 inch on the bottom. And you can see that the inches cancel. And so that's what we mean by a dimensionless quantity. And so this would end up being, theta would be 5 radians. So to continue with regard to that, you can see that we've defined, as I showed you on the whiteboard, theta equals S over R. And again, it's really important with regards to the idea of it's a dimensionless quantity. The next one we'll talk about is degrees, and degrees has a dimension to it. So we have to think about that with regard to that. But if you remember from your geometry days, if you take the circumference of a circle and you go all the way around the circle once, if you remember, that's the definition again would be 2 pi times the radius, which is r. And so we'll be using this relationship quite a bit throughout the first 3/4 of this class with regards to understanding how far you go around the circle and being able to measure the angles. And so you can see from here is that you remember that if you go all the way around the circle once, that would be 2 pi. And if you remember, pi is the number 3.14 and blah, 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 blah. I think it's 3.14159. Those are the ones I remember. But with regards to that actual value, when you're doing calculations, if you want to just use 3.14, 100% okay with me. And the idea that a lot of the calculators already has a pi value built in, and you could hit like shift pi, and that number would come up for the calculations as well. So if you go all the way around one time, that's 2 pi around the circle, and you could see that if you round to the nearest hundredth, that number would be 6.28. And so you could see as we go around the circle, if you go around half the time, halfway around, that would be pi. If you go a quarter of a way around, that would be pi over 2, etc. And so one thing that's really important with regards to starting to think about these angles is that if we take a look at this particular one, and we think about this is the 0 point. And if we have a circle that goes all the way around like that, it's not a bad circle. And so if you go from here, the x-axis, right, positive x-axis, over to the positive y-axis, you go around a quarter of the revolution. And so at this point, the angle would be pi over 2. If you go all the way to the negative x-axis over here, this would be pi. If you go all the way down to the minus part of the y-axis, this would be 3 pi over 2. And then if you continue all the way back, you do one complete revolution, we would measure that angle as 2 pi. So here's a couple examples with regards to what I talked about and in the whiteboard. And so that idea with regards to moving around those, here we're all going in the counterclockwise direction, so everything is positive with regards to that. So I'm going to stop this lecture here and continue trying to make these shorter chunks of lectures so it's easier to absorb. And I will see